Alright, so the first thing you want to do for number 15 is you want to get the log by itself. So if you ever have just one log, you always want to get that log by itself. Meaning anything inside the log will stay, but anything outside of it won't. So what do I need to do with this 5? Subtract it, good. I'm going to subtract this 5 on both sides, which is going to leave me with log base 7 of negative 2b is equal to 2. And then, do you remember the arrow method? So that's going to be 7 to the second power is equal to negative 2b. Well, 7 to the second power is actually 49. And then my last step to solve for b would be to
subtract that, or divide by 2.
Good. Divide by negative 2, which would give me b equals negative 24.5. Alright, so we are going to go over number 20 if anybody is interested, if you haven't done it yet. So you deposit $1,000 into an account that pays 5% annual percentage rate, compounded weekly. State the value of the account in 9 years. We can start. So it says you deposit $1,000, this is your P value, your principal, into an account that pays 5%, so 0.05, compounded weekly. State the value in the account in 9 years. So if it's compounded weekly, how many times in a year is it compounded? Good, 52. And this is your N. And this is T. So it's going to be A of 9 is equal to 1,000 times 1 plus your rate divided by 52 to the power of 52 times 9. So A of 9 is equal to 0.05 divided by 52 plus 1 to the power of 52 times 9 times 1,000, and I'm getting 15,000. No, just kidding. It's not 15. That would have been nice, but it's not. It's 5,000 or 1,567 and 97 cents. Yeah, that's what I'm saying. Like, I don't feel like this was a really good. Yes.
I'm confused because I got 1,542.
Huh. Let me see how you did it in the calculator.
How did you do it?
I can show you that too if you want.
I got the same thing as you.
You got the same thing as me?
Yeah.
I just have a different calculator than you, so that's why I wasn't sure if you wanted. I just like put lotion on my hands. Okay. So the first thing you're going to do is you're going to divide 0.05 by 52. So 0.05 divided by 52. And I get this. And then add 1 to that. And then you could have either multiplied ahead of time 52 times 9, or you can do power of parentheses 52 times 9. Oops, I just messed up. 0.05 divided by 52 plus 1 to the power of parentheses 52 times 9 close parentheses equals times 1,000. What happened in yours, do you know?
I think I just messed up with the part. That's like which one to do first.
I think the hard part about this one, and if it were me, like when I first started learning this, I probably would have multiplied 52 by 9 first.
Yeah.
So I don't have to do that thing to the exponent, it's harder. Because then you can just put it to the 468th power. Yeah. It'd be easier that way. So does anybody else have any questions about how to use the calculator on that? Alright, so number 19 says, the graph reflects a 25% annual depreciation of a new boat after 10 years. So depreciation means that the value is going down. Yes, so as you can see, the value is going down. So what do you think time 0 represents? Right here. What does time 0 represent?
Probably newly bought.
Yeah, newly bought boat. So basically, we can see from the graph that when the boat was purchased, it was purchased for $3,500. Everybody see how I figured that out from the graph? And then its value depreciated over that time at a 25% rate over 10 years. So it says, derive the decay model represented by the graph. So basically, they want us to come up with the equation that suits the graph. So if you remember, this is just regular traditional exponential decay. It's not the continuous one because they don't say anything about that. So that is A of t is equal to A sub 0 times 1 plus your rate to the t power. Oh, I'm sorry, minus. It's decay, so it's minus. So do you guys remember that formula? So this is the formula we would use because this represents exponential decay. And then from here, we're just going to be plugging in for the initial amount, which is $3,500, and the rate, which is 0.25. So that would be your formula. Now, I'm kind of out of room, but if you want to actually simplify this, 1 minus 0.25 is 0.75. So you could have also replaced that with 0.75. But that's the equation. And then it says, use the model you derived from part A to calculate the exact value of the boat after 6.5 years. So what am I going to do with this formula now?
You're gonna plug in 6.5 for your time.
Good. And how do I know I don't need to change the units on years? Was there an indicator for that?
No.
Look at this word right here.
Mm-hmm.
Annual. So that's how you know that the rate was in terms of years. So you're able to plug years into your formula. Because that's something that, can be confusing. Oh, and you should replace t with 6.5. Yeah. So then that's going to be A of t, which is A of 6.5 is equal to, so you would do 0.75 to the 6.5 power times 3,500, which comes out to be $539.47. So basically, after 6.5 years, the boat is only worth under $600. And does your calculation in part B match the graph? So to see if it matches the graph, I can zoom in a little bit here. So 6.5 years would fall right here.
Yeah.
So does it match what we came up with?
Yeah.
Yeah, it does. So you would say yes. And then I would put a little point on the graph where that is so you can see, where that came from. So this problem really wasn't that hard. You just had to know to look at I feel like the first part, knowing to find the initial value, was like the most key important part here.